Good morning students, welcome to the session on data structures. Okay, this is the first topic that we are discussing in your second unit, I can say. The first topic that we are going to see is the recursion. What is the recursion? A recursion function you might have studied in case of C and C++. In the C language also we will be seeing the recursive functions, and in C++ also we will be seeing the recursive functions. Okay, what is the recursive function? The function which calls itself is called as recursive function. Say suppose any function is calling itself for number of times, then that function is called as recursive functions. The functions which calls itself is called recursive function. Recursive function. Okay, you people might have seen lot of examples for these particular recursive functions, like finding the Fibonacci series and finding the factorial of any number. Okay, just I am giving you the idea that you people have seen this particular topic in C and C++. What is the recursive function? The functions which call itself is called as recursive functions. How the function will make a function call? By using its name. Say suppose if I am having a factorial function, then it must return some integer value. I will be taking the return type as integer. Say suppose if I am having a function name called as factorial, and within the factorial I will be sending some number, some n number. For number n I am finding what? Factorial. Okay, in order to find that factorial I will be writing the code like this. If n is equals to 1, then return 1. Factorial of 1 will become what? 1 only 1. Factorial of 0 will also become what? 1. As you people are mathematical students, I won't tell how it is 1. Okay. Factorial of 0 will become 1. Factorial of 1 will become 1. That is the reason I am giving a condition. If your given number is 1, then return 1 for the factorial. Okay. Else, if it is not 1, then go for else part. Do this. Return n into again I am calling the same function, that is fact of n minus 1. This is my factorial function. See how I have written the code. In generally factorial of see the example. If I am finding the factorial for 3, factorial of 3 will be found like this: 3 into 2 into and 1. Then the final answer will be 6. Okay, like this we will be finding the factorial of given number. In order to do that, I am writing this coding part. The function which calls itself is called a recursive function. My factorial function is a recursive function. Why? Because the factorial function is executing some statement. Within those statements, again it is calling the factorial function. Factorial function, in turn it is calling the factorial function. That is the reason I am calling this factorial function as what? Recursive function. See how it will be executed. See, I will be having main functions, I will be declaring n variable, I will be sending the variable. This you know already. Just mainly focus on your recursive function. Say suppose if my n is 3. If my n is 3, then I will be sending, I will be calling the factorial of 3. Somewhere in the main function I will be calling this fact of 3. Then your function will be called, your control will go from main function to your factorial. Then it will be executing this part. Whether 3 is equals to 1, no, it is not true. Then I will be going for else part, and I will be writing this. N is what? 3, and into factorial of 3 minus 1, that is 2. Factorial of 2. Again I am making a function call called factorial of 2. Then the function control again moves to your factorial function. Okay, n becomes 2 in this case, and then 3 will be stayed in your factorial function only. 3 will be 3, and see in this factorial function, I am returning this. Again the n value is 2 here. 2 into factorial of n minus 1, that is 2 minus 1, that will become 1 here. Again in turn into this we are making one more function called to the factorial. Now the n is 1, then if 1 is equals to 1, then return what? 1. Then your function will return 1 here. Then I will be doing this. 3 into 2 into 1 will become what? 6. Like this we will be finding the factorial of any number by using what? Recursive functions. See, generally in the main function I will be calling the factorial for once, and in turn in the factorial function I am calling this for 2 times. Okay, then try to understand this. In generally the program will look like this. This is your factorial function. In the main function I will be declaring a variable called int n is equals to 3. Then I will be making a function called here. Say suppose if I am declaring one more variable for holding the factorial, say suppose some factorial variable, then this factorial variable will hold whatever the value that has been written by your fact of n. N is what? 3. I am sending 3 to your factorial number. Factorial will hold the factorial of that particular number. Now when I am making function call from this main function, then the control will move from this to this function, and it will be executing this part. In this particular part, you see, for the first time I have called it from the main function. In turn in the function it is calling the factorial for 2 times. Okay, this will become your depth of the recursive function. Depth of recursive function. Recursive function mean to say that how many times you are calling inside. I am calling it for 2 times. Okay, your recursive calls, your recursive function should have some end point. I am having an end point over here. If n is equals to 1, then I need to end the factorial function. End the function here. If you are not putting this restriction towards your recursive call, it will be executing it for number of times. Even after becoming 1, then it will take 0, then it will take -1, then it will take -2. Like this it will be doing the process for number of times. There will be no limit, there will be no answer, I can say, if you are not putting any n towards your recursive function. Then that will be called as endless recursive function. Endless recursive function. Endless recursive function. Then see, these particular recursive functions can be implemented by using your stack. Okay, by using your stack. How we will be implementing the recursive function by using the stack? You see, these are the steps that I am executing in your recursive function. So consider if my stack is this, then whenever I am making a function call to your factorial function, then I will be storing my n into that. See, when I am executing this for the first time, then I need to store what? 3 here. For the first time when I am executing, this 3 will be stored, or else this 3 will be pushed onto your stack. I will be holding this in your stack. Okay, again in turn it is invoking the factorial function again it will be making the call, and in turn we need to store what? 2 here. That 2 will be pushed onto your stack, and again we are making a function call to your factorial by sending 1. 1 has to kept in your stack, but it will return some value, that is 1. It is done with the function is returning what? 1 will be kept onto your stack. Then after this I will be popping each and every element from your stack, and I will be doing the multiplication. First pop into second pop operation, and then into third pop operation. See here, first pop operation will return as 1, and the second pop operation will return as 2, and third pop operation will return as 3. In turn, it will be giving us the result as 6. 6 will be stored onto your stack. When the stack is having only one element, that will be given to your main function. That will be displayed onto your main function by using the stack. In this way, we will be storing the elements, I can say, in your recursion. If we are having limited size to our stack, say suppose your stack is implemented with the array will be having some size. Say suppose your stack is containing some 50 elements, then you can insert only 50 elements. You will be not inserting 51 element. Okay. In this way, we will be having some restriction towards our stack, which will lead us to the stack overflow. Stack overflow. If you are doing something wrong, say suppose if you are giving some 50 factorial, then we need to store 51 elements. Say suppose 51 factorial, 52 factorial. If my stack is having only 50 elements size, then we will be throwing an error message that stack is overflowed. Okay, and in this way we will be using your stack in order to implement your recursive functions, I can say. Just do remember, very useful when you are going for your external exams. And we will be using two more words when we are doing the recursive functions by using your stack: winding and unwinding. Winding is nothing but pushing the element onto your stack. Pushing the element onto your stack is called as winding. And unwinding is a process of deleting or as a removal of your elements from your stack is called as unwinding. Okay, these are the related words which will be used in case of your recursive functions when we are executing the recursive function calls by using what? Your stacks. Okay, these are the few things that you need to remember in case of your recursive functions. Okay, I hope it is clear how you people are calling the recursive functions, how in turn it will make a function call, how it will be written onto this. If say suppose if I am printing the statement in your C language or C++, then I will directly go for C out factorial. Factorial will print us the factorial value, okay, onto the screen. So if you want to implement by using the stack, then again you will be declaring a class, you will be taking a stack, you will be storing the each and every element onto the stack, you will be popping out the elements. Just here the problem is that you need to understand the recursive function. No need to go for your class, main function, each and everything. But here we are mainly focusing on what? Your recursive functions. How the recursive functions are executed, how it is executed by using the stack. That is what the important concept that you need to understand in this particular session. I hope it is clear. See you in the next one. Thank you.